Hello and welcome to Year 8 Chemical Interactions with Mrs. Castanera. Today we are looking at Lesson 8, how do the processes of filtration and distillation work? So today's lesson is called Separating Mixtures, and we are going to use the following keywords, many of which are already familiar to you: solute, solvent, solution, dissolve, soluble, insoluble, ions, filtration and evaporation. So I'd like to pause the video and complete the knowledge check, please. There are 8 questions. Okay, so we're going to go through that. Give 3 examples of everyday mixtures. So there's many options for this, but the 3 examples listed last lesson were inks or dyes, blood, and rock salt. If you're not sure if your answer is correct, ask an adult at home or email me. Complete question 2. A substance that dissolved in a solvent is called the solute. 3. State what a small RF value means about the solubility of an ink. It means it is low soluble or low solubility. So not very soluble, doesn't dissolve well. Elements are made of all the same type of atom. Mixtures are made of different types of substance. Name the process when a substance changes from a liquid to a gas. So that's evaporation. Or you might have said boiling. Name the point when a substance changes from a liquid to a gas. So that is boiling. So that's the boiling point. And name the process when substances change from gas to liquid. That is condensation. So if you could give yourself a mark out of 8, please. If you've got 4 or less, I strongly recommend you review the knowledge check before starting the rest of the lesson. So, the overview for today's lesson, we will be describing the processes of filtration and distillation. Mixtures. Some mixtures occur naturally in the world, but the individual substances they are made from can be more useful on their own. We can use various techniques to separate mixtures depending on the substances they are made from. There's lots of options for separating mixtures. So, if you had mixtures of sand and rock, you might want to sieve it. Other things include chromatography, or we can filter, which you've done at school with filter funnels, filter paper, to separate liquids or things dissolved in liquids from solids that don't dissolve. We can use evaporation, so evaporating the water off of something such as salt dissolved in water. You can evaporate the water off to leave the salt crystals behind. So we're going to look more into this today. So rock salt is a mixture of sand or rock and sodium chloride, known as salt. As a mixture, we place it on icy roads to make them safer to drive on. The salt melts the ice, and the rock provides better friction or grip to stop the cart sliding around. However, the salt and rock can be separated and used in other ways. So we're not going to complete this investigation as we don't have the stuff to do this at home. There will be a video and I will show you how to access the video now. So again, you need to go back to the YouTube Cognito page, and we're looking for the GCSE Chemistry, and you go through to the playlist, and we're going to go down this time to Filtration, Evaporation and Crystallization, video number 49. I want you to watch the whole of that video, please, and then once you've done that, you can return back to the booklet, please. Learning Activity 1. separating mixtures. So it's important to know some of the properties of the individual substances before deciding on what technique or which technique to use for separating. So the technique you use is going to depend on the properties of the individual mixtures. So rock salt is made from insoluble sand and soluble sodium chloride. Okay, so we know that sodium chloride dissolves in water, but sand will not dissolve. And that is the property, its solubility, that will be used to separate it. So filtration, this is what happens during the process of filtration. And you're going to want to have your student notes page on hand nearby to write out some extra information here, because there's just not enough room. So, filtration. You would mix the rock salt with the water, okay? And the purpose behind that, we're going to move to the notes page. 1. We're going to add the solvent to the solid soluble mixture. So, add solvent to the mixture of soluble and insoluble substances. I'm going to give this a title. This is going to be Filtration, Evaporation, and Crystallization. And I'm going to underline that with a ruler. So step 1, add the solvent to the mixture of soluble and insoluble substances. Step 2 is filtering to separate the insoluble and soluble parts. And as it shows on page 39, it talks about folding a circle of filter paper into a cone and placing it into a filter funnel over a boiling tube, or you can also do it over a conical flask. And the idea of it is you stir the contents of the beaker using a spatula to mix them up, and then immediately pour the whole thing into the filter paper, so that the idea is you stir it so you don't leave lots of sand behind in the beaker afterwards. And then the filtrate, that's the water and whatever's dissolved in the water, will appear in your conical flask or your boiling tube below. So filtrate, this is an important word we need to know. That is the solvent, well, it's actually the solution. So the filtrate is the solvent plus solute, so that's the soluble item that turns into a solution. And the point of the solution, the reason we call it a filtrate, is it's a solution that has passed through a filter. In this case, the filter paper. Okay, so we're going to add in these points now onto our notes. So step 1 was adding the solvents. So at this point, after we've added the solvent to our mixture of soluble and insoluble substances, we will have a solution containing the soluble substances, as well as the solid insoluble substances just floating around in the mixture but not dissolved. So the next stage is filtration. So this is what filtration is. We're going to use a filter, in this case filter paper, to separate the insoluble solids from the solution. The solution of solvent and solute. So the solution is the solvent and solute. So in this case, the water and the sand. So the solution is salt water. Part 3. And you do need to know this because you'll regularly ask this as a 6-mark question in exams, so you will need to learn this system of how to separate this. Insoluble parts substance really are left behind, and it's important to say this, on the filter paper. So that is the process of filtration. We've separated our insoluble substances, which are left behind on the filter paper, and you can dry those and to have it separate completely from water. So we'll say allow to dry. Okay, so we've got dry insoluble substance, in this case the sand and rock, left behind on the filter paper. And we also have a solution of water and salt, not sand. So we have a solution of water and salt, which is the salt water, which is separate to our insoluble sand. Okay, so after evaporation, in fact before we carry on, we're going to go for some observations. So state the substance left behind on the filter paper. Suggest which substance would be found dissolved in the filtrate. And explain why the substance was left behind on the filter paper, not in, but on. Okay, so answer these 3 questions for me. Pause the video whilst you do that. So let's go through those. Question 1, it was the rock and sand mixture that was left behind on the filter paper. And that's because it's not soluble. So the reason for the substance being left behind in the filter paper is it's insoluble. And the substance that will be found dissolved in the filtrate is salt. You may have said sodium chloride. Either is fine. So there's 3 marks there. Hopefully you got all 3 right. If you got 1 or less, then you really need to review that again. So we're going to move on to evaporation. So step 1, warm the contents of the boiling tube. You could do it over the Bunsen burner, but don't boil it. Okay, you want to warm it to allow evaporation to speed up. Okay, now the point here is we are going to be encouraging the solution to become saturated or oversaturated so that the water is going to evaporate off, leaving behind just our solid, which was previously dissolved in the water. So I want you to answer the question, why does the water evaporate but the salt does not? Pause the video whilst you do that. Okay, so the reason for water evaporating, but not the salt, is at different boiling points. They have different boiling points. The water's boiling point is much lower than salt. The water boils whilst the salt is still a dissolved solid. So basically, you need to explain that the water's boiling, so anything around boiling would get you the mark, but the salt doesn't boil until a much higher temperature. So anything along the lines of the salt is solid at that temperature, or it boils at a much higher temperature, anything along those lines. So the fact that it's still a solid. So there's 2 marks here for this. Give yourself a mark out of 2. Crystallization, which is the 3rd part. So we had evaporation before, now we're on to crystallization. So we can pour the contents of the boiling tube into an evaporating dish, that is literally a small bowl-like dish designed for evaporating water, and we leave it in a warm, dry place until crystals form. So explain why the salt forms crystals as the water evaporates. Well, the idea here is that when the water evaporates, the solid salt crystals are going to be left behind because they do not evaporate at room temperature. Salt requires much, much, much higher temperatures to even turn into a liquid, far less turn into a gas. So, why does the salt form crystals as the water evaporates? So, evaporating water means that the salt has no water to be dissolved in, so it forms new solid crystals by bonding to other salt molecules. So when the water evaporates, leaving behind sodium and chloride ions, they are then attracted to each other, the ions, creating ionic bonds. Okay, so there's no water left anymore, so the water can't be attracted to the sodium and chloride ions, so they're now attracted to each other, going back to ionic bonds, which is a solid substance. There we go. Okay, so we're not going to mark this one because this one was very difficult. This is a do it together one. So we're going to add to our notes about evaporation and crystallization on the notes page. So part 4, evaporation. So we're going to heat gently the solution, or filtrate, in fact. Both these terms apply, so it is a solution of salt water. It's also a filtrate because it's passed through a filter, until most of the water has evaporated off. Okay, so this heating part is just to speed up getting rid of the water. It would take a really long time, weeks and weeks otherwise, to get rid of all that water. So part 5 is when there's very little water left, and that is the crystallization process. And so we place the filtrate or solution. At this point, it's something called a saturated or even oversaturated solution, which means there is an awful lot of sodium chloride, salt, and not a lot of water there. So you can place the solution or filtrate, and we place it into an evaporating basin and place in a warm, dry location such as a windowsill or above a radiator. So what will happen here is that the remaining water will evaporate, leaving behind solid, ionically bonded salt crystals. Okay, so that is our summary of filtration, evaporation, and crystallization. So we're going to move on to a new technique called distillation. There's a separate video for this one as well, which I will show you. So again, you'll need to go back to the Cognito part on YouTube, so the Cognito page on YouTube. And again, we're looking for the GCSE Chemistry playlist. And this time we're looking at video number 50, which is GCSE Chemistry, Fractional Distillation and Simple Distillation. So I'd like you to watch the whole of that video, please, on distillation, and then return back to the booklet. So sometimes mixtures are made from only soluble substances. So this process of filtration, evaporation, and crystallation is not going to work. Filtration would be an inappropriate technique for separation. So alternatively, we need to look at other properties that the substances have to decide which technique would be more suitable. One common property that varies between different elements and compounds is melting and boiling points. So heating a mixture gradually to allow the different substances to boil at different temperatures, to the next page here, will result in them boiling at different times, which allows us to separate them. So different substances boil at different temperatures and therefore at different times, which allows us to separate them. And this is the whole theory behind distillation. So we could, for example, separate water and ethanol by distillation. Water and ethanol are miscible liquids. Miscible means to mix, from the Latin miscere, to mix. So miscible liquids means that they form a homogeneous, so all the same, mixture. So you can mix them together and you can't tell which part is which. Okay, so form one consistently the same mixture and it all looks the same. So, but the difference is that water has a boiling point of 100 degrees Celsius and ethanol has a lower boiling point of 78 degrees Celsius. And it's this property that we'll use to separate them. Now the way this works is we have our water and ethanol, our mixture, and we place it in a round-bottomed flask. I'm going to label this as the round-bottomed flask. Okay, and the round bottom flask is placed over an electric heating element, not a Bunsen burner. And the reason is a Bunsen burner with a naked flame, that's what we call a flame that is not surrounded or covered by anything. That's too dangerous because ethanol is extremely flammable. Okay, so that's why we use an electric heating element. So if you're ever asked to describe this experiment, please do say that the heat source must be electric or not a Bunsen burner. You could say a heat plate, but as long as you don't say Bunsen burner to heat it, or you specify that the heat is not from a naked flame. So the round bottom flask is connected to a condenser. So here's our round bottom flask. The top of the flask is usually around about here. And then we have our connection to this, which is the condenser. Okay, so this is the condenser. And this whole tube is the condenser. And the condenser is a glass tube that has cold water, and the cold part's important, flowing around the outside of it. So the inside of the tube is dry, but it has a special sort of cold water jacket surrounding the tube, a bit like when you put an ice pack around your lunchbox, for instance, or around something you want to keep cool. It wraps it in cool water to cool down the gases passing through this tube. So water, in fact ethanol, will evaporate first at 78 degrees Celsius, and ethanol will be a gas at this point. When it passes down this tube and hits the cold glass on the outside of the tube because of the cold water flowing around it, it will turn back into liquid ethanol. And the liquid ethanol drips down the side of this tube, which is downwards at a downwards angle, much like water drips down the shower glass, the glass in a shower, and then it falls into this test tube or boiling tube here. Okay, which collects pure ethanol. So this is pure ethanol now. So we have the boiling tubes in this case ready to collect the contents. So the ethanol evaporates at a lower temperature and therefore sooner than the water. And so the first liquid, this is definitely ethanol. And you'll be leaving behind probably a little mixture of ethanol and water. And you can prove that this is ethanol because you can pour it onto a heatproof mat and light it. Water wouldn't light. You can literally light that ethanol on fire and it's very obvious that it's on fire, so it's clearly ethanol. So that's really important to know that you can prove the first liquid is ethanol by pouring it onto a heat-proof mat and lighting it. It's very important that we talk about putting it onto a heat-proof mat because we would not want to light the desks. Okay, now this is called simple distillation. You will sometimes hear this called distillation, but simple or just distillation is fine. Simple distillation is the better way to refer to it. And the reason is that there's other types of distillation. Some of them are called fractional distillation, which we'll learn at a later time. So we're going to write a little summary at the bottom here, not much, just a sentence or so, to summarise what happens in this picture. I think we'll do it in a regular pen. So ethanol boils at a lower temperature than water, so is collected first. So if you make sure you've got all these annotations and writing down, please. Okay, so lastly, it's the quiz. So I'd like you to complete the knowledge and application check, please. There are 9 questions. If you need to, you can use the notes page, particularly for question 9, which requires a bit more writing. Okay, so we'll go through that now. So, solute plus solvent turns into a solution. Name the process that separates sand from salt. That would be filtration. Explain why sand can be separated from salt. Sand is insoluble in water, but salt is soluble in water. Ethanol and water can be separated because they have different boiling points. The word that describes 2 liquids that mix easily is miscible. Watch out for the spelling on this one. The process by which liquids change to gases is evaporation, or you can say boiling. Name the process when substances are separated according to their boiling points. So simple distillation, or just distillation is fine. So you don't have to say simple. State the point at which substances change from a liquid to a gas. That is known as the boiling point. And lastly, describe an experiment that could be used to remove the salt from seawater. Include the scientific names of any process involved. So, if you Googled this and wrote reverse osmosis, then you would be wrong. I mean, technically, you would be correct. That is a process of removing salt from seawater. However, that does not use any of the knowledge we've learnt this lesson. So unfortunately, that is not correct and would not gain you any marks on the exam. What they're looking for is 1, evaporation. So you heat the water. So you heat the seawater to remove water. 2, crystallization of the salt. Okay, so you just leave it in one place. That's it, part 1 and 2, so it's 2 marks there. Stage 1 is evaporation, and stage 2 is crystallization, and you need to have a brief description of each. You may have also added that crystals form, or solid crystals form. Okay, so part 1, evaporation, brief description. Part 2, crystallization, brief description. So give yourself a mark out of 10, please. If you got 4 or less, you need to review this lesson again and look at your knowledge organiser. If you got 8 or more, excellent work, well done. Anything between that is absolutely fine, you're doing well. And that is the end of our lesson, thank you.